In this video, we are going to introduce the idea of hypothesis testing. And a hypothesis test is kind of what it sounds like. The word hypothesis, you probably have some ideas about what that word means. You've done it in a science experiment back in elementary school or middle school or something like that. A hypothesis is just an educated guess. And in this case, it's going to be some sort of statement that is backed up by some sort of evidence. So we will have some evidence that supports this particular hypothesis, and we'll try to test and see whether that hypothesis is actually true or not. So that's going to be the idea. We want to test whether a hypothesis is true. And so in the context of our statistics class, we're always going to define two different hypotheses. So we will define two hypotheses. Okay, so we're going to have basically two different things. And they're, in a sense, going to kind of be almost mutually exclusive ideas, or they're almost going to be the complements of one another. Not quite, but we'll see exactly how this works in just a minute. So let me give you an example, and then we will define these two hypotheses in the context of the example. So let's say there's a restaurant, and they attract, on average, maybe 128 customers a day. A restaurant averages 128 customers per day. And they do some sort of change in hopes of increasing the number of customers. So maybe they changed the menu or something like that. They change the menu in hopes of drawing more customers. Typically, one of these problems will also have some sort of evidence saying that after this menu change, maybe they drew 130 customers per day. And so they'll have some sort of evidence either stating that we think that this change worked or that it didn't. So I'll sneak that in here. These won't always have this evidence stated, especially in this section. So after the change, they averaged, 131 customers per day. And we want to know whether or not basically this menu change was effective. Did it have the desired result? So here's the two possibilities. Here are our two hypotheses. The first one we're going to call the null hypothesis. And in math, the word null basically means nothing. So the word null means nothing or zero, and in this case, the null hypothesis is going to be that there was no change. Nothing was different after they changed their menu. And that whatever differences we did see, so the fact that it went from 128 customers to 131 customers, that was due totally to chance. It wasn't actually a result of the menu change. So this is the idea in this case, that the new menu doesn't change the number of customers. So in this case, basically what we're saying is the average number of customers, which we're going to call mu, is still going to be equal to 128. And the notation that we'll use for this is as follows. So we'll do a h with a little 0 down below it, and then we'll do a colon. This is just meant to be a label that indicates here's where we're talking about the null hypothesis. So this isn't something mathematical, it's basically just a shorthand notation, so I don't have to write out the words null hypothesis. And the colon just says, okay, here's the null hypothesis. We're about to state some mathematical sentence, so to speak, that tells us what the null hypothesis is. And in this case, the null hypothesis is that mu, our average number of customers, is still going to be 128. So that's what our null hypothesis would be. The alternate hypothesis is that it did work, and we actually call it the alternate hypothesis. So our second hypothesis is called the alternate hypothesis. And this is what the evidence showed, that there was a slight increase in the number of customers. So the new menu does increase the number of customers. And the notation we'll use for the alternate hypothesis is going to be a capital H with, instead of a 0, we're going to do a 1. So these are our two forms of our different hypotheses. Whenever you see an H0, we're referring to the null hypothesis. Whenever you see an H1, we're referring to the alternate hypothesis. The null hypothesis is always going to be that nothing happened, nothing changed, there's no difference. It wasn't effective, essentially. And the alternate hypothesis is always going to be the thing that was supported by the evidence. In this case, our evidence showed that the average number of customers went up to 131, so that hypothesis says it looks like it did increase the number of customers. And the way that we will write that is that we think mu, the average number of customers, is now going to be greater than 128. So we'll see this in just a minute. We'll do some more examples, but this is kind of our starting point. This is always going to be the first step of a hypothesis test, is defining these two hypotheses. And it turns out, as we go through and do actual problems, this is honestly one of the hardest parts, is correctly picking the null and alternate hypothesis. So we'll practice this a bunch going forward. Okay, so in short, the null hypothesis typically means that it's the hypothesis that there was nothing changed. And the alternate hypothesis this is going to be the thing that's supported by whatever evidence is given in the problem. So this is going to be kind of the idea going forward. The alternate hypothesis can take three possible forms. So there are three forms of the alternate hypothesis. And here are those three forms. We could have H1 state that the value of mu is greater than some number. In this case it was 128, but I'm just going to put a generic placeholder mu 0. That's what we'll use. So that mu is greater than some number. We can have that mu is less than some number, or we can have the alternate hypothesis be that mu is simply not equal to some number. This number, this mu 0, this will be the number, so mu 0 will be the number associated with the null hypothesis, H0. So going back up to our example we just did, this number right here, up here in our null hypothesis, that is the number that's playing the role of mu 0. So that's the number that mu 0 is just sort of a generic placeholder for. Looking at these three forms, we're going to have different names for these things. This first one, where mu is greater than mu 0, this is what we call a right-tailed alternate hypothesis. The next one is called a left-tailed alternate hypothesis, and the last one is called a two-tailed alternate hypothesis. And this will all make sense when we actually start doing these problems. So once we actually do some examples. It's going to have to do with the drawing of our normal distribution, our normal curve, and kind of looking at where the information related to the problem shows up. Does it show up in the right tail, the left tail, or in both tails of our drawing? So we'll see that probably in the next video. So let me just do maybe one other example just to kind of get a sense of whether or not we understand what the null and alternate hypothesis mean, and we can try to identify what our tail is. Are we left-tailed, right-tailed, two-tailed, etc.? Okay, so in this example, we're looking at bags of chips. So bags of chips are labeled as containing 16 ounces. But an inspector weighs a few, so they suspect, based on some evidence that's not even mentioned in the problem, that I'm not going to specify. When we actually do these problems, we'll specify that evidence, but for now, I just want to figure out the null and alternate hypothesis. We don't need to know exactly what the evidence is. So an inspector suspects that the mean weight is actually a little bit more, that they've actually been overfilling these bags of chips. Let's see here. So I just want to state the null and alternate hypothesis. So again, the way that we do it is with our two statements that start like this. Every one of these problems will start with this. We've got our place where we're going to state what the null hypothesis is, and we have our place where we're going to state what the alternate hypothesis is. The null hypothesis is always going to be no, he's wrong. There is no difference. There is no difference between what's claimed and what is actually seen. So in this case, it will be that mu is equal to 16 ounces. And the alternate hypothesis is always going to be the thing that is supported by whatever evidence is given. So in this case, the inspector thinks that the mean weight is actually more than 16 ounces. So the alternate hypothesis is that mu would be greater than 16. And that makes this thing, looking back at our list up here, so do we have a right-tailed, left-tailed, or two-tailed hypothesis? Well, in this case, we've got mu greater than some number. That number happens to be 16 in this case. So we have a right-tailed hypothesis. So this is right-tailed. A couple of things that I want to point out that will make this a lot easier for you. In general, these two numbers will always match. So if you've set up your null and alternate hypothesis correctly, it's the same number that shows up in both of the two places. They're both that mu naught number that we had before. The second thing that's always going to be true is that this right here is always going to be an equal sign. So we'll never use another symbol here. We'll always use an equal sign here. Even if the phrasing up in the question makes it seem like maybe we should use a different symbol here, it doesn't matter. We will always use an equal sign. And again, we will talk about that a little bit more as we do some additional examples. So I'm going to have that be it for these examples. There's more that you can look at if you want to read the book, and we will do more as we continue to do a bunch of problems. But the idea is, once we have these two possible hypotheses, our goal is to decide which one we're going to go with. So once we have our two hypotheses, we want to determine basically which one of them is correct. And the way that we do it is by focusing on the null hypothesis. So which is likely to be true? So this is important. We're going to focus on the null hypothesis. Essentially, what we're going to do is assume that the null hypothesis is true and kind of go through this thing like a criminal trial. We will lay out exactly the ways in which this is similar to a criminal trial in just a minute. But basically, we want to decide, so we're going to focus on the null hypothesis, and we want to decide whether it's true. And if we conclude that it's not true, then we'll accept the alternate hypothesis instead. If we determine it's not true, then we will accept the alternate hypothesis. Okay, so as I just said a minute ago, the whole thing is a lot like a criminal trial. So let me sneak that in here. It's like a criminal trial. And I'll list out the ways in which that is the case. So the first way that these things are similar is the idea in a criminal trial. Hopefully you've watched your Law and Order, so you know what's going on here. But the first one is the presumption of innocence. So we start off with the assumption that it's innocent until proven guilty. And what I mean by this is going back up to our example that we did a minute ago with our bags of chips, we're going to assume the null hypothesis is true. We're going to assume that they haven't been overfilling these bags until we can prove, based on this evidence, that that's not the case. So innocent until proven guilty is the idea that we're going to always start with the assumption that the null hypothesis is true. So H not being true is the idea of being not guilty, that nothing weird has happened, they didn't do anything, and then we're going to examine the evidence to see whether or not we can keep in good conscience the idea that this person is innocent or that this statement is true. And so that's going to be the second step. We're going to look at the evidence. The evidence is always going to suggest that H naught is not true. It's going to suggest that the person is guilty. Otherwise, this thing wouldn't have even gone to trial. So we're going to consider the evidence. So the evidence is against H naught. And as we said before, it's always going to be the thing that supports the alternate hypothesis, which is essentially saying guilty. As we saw in this example with our bags of chips, this evidence, which was unspecified, indicates that the bags weigh more than 16 ounces. So there's some indication, there's some evidence that the null hypothesis is false, that the true weight of the bags is not 16 ounces. There's evidence that refutes this idea and that supports this. We want to figure out how strong that evidence is. So the evidence is against H naught. It supports H1. And we want to look at all of this data or evidence to see if it strongly, beyond a reasonable doubt, suggests that the null hypothesis is false. So in a criminal trial, that is the burden that you have to clear, beyond a reasonable doubt. That's essentially what we're trying to do here. We have some evidence. Is it strong evidence? We'll talk about how we can decide mathematically how strong the evidence is when we do an example in the next section. And at the end, we render our verdict, just like in a criminal trial. So we'll render our verdict. So if the evidence, if we decide that it is really strong and that H naught is false, we are going to reject the null hypothesis. So if the evidence is strong, we'll reject, right? Again, the idea is we assumed H naught was true throughout this whole process. If the evidence is strong that it's false, we'll reject H naught and instead accept H1. So we will reject the null hypothesis and accept the alternate hypothesis. But if the evidence isn't strong enough, so if it's too weak, if it's insufficient, then what we'll basically say is that the null hypothesis may be true. We'll never say that it is true. We'll never know for sure whether this person is guilty or not, but we just will say the evidence wasn't strong enough to convict this person. That's kind of the idea. So we'll say that H naught may be true. And this is important, may be true. We'll never say that it is true. We'll just say this person may be innocent, so we don't have strong enough evidence to convict. That's kind of the idea. So, just like in a criminal trial, the end result of the whole thing can sometimes be wrong. Juries can get the whole thing wrong. Let's leave a little bit here. So I want to talk about the different types of errors that can be made. So these are the errors in our hypothesis test, ways things can go wrong. Let's write it like that. Come on. There we go. No? Okay, I'll live with it like that. Okay, so basically the question is, what if we screw up? What are the different ways that we can screw it all up? So I'm going to write a little table here. On this part, I'm going to put the decision that we wind up making, whether to convict or not, basically. So are we going to reject the null hypothesis? This is our guilty verdict. Or are we going to not reject it? So we may, if we don't reject H naught, that's the same thing as saying not guilty. We aren't saying innocent, we just say not guilty. Right? So here are the possible decisions that we could make. And over here I'm going to put the actual reality of the situation. There's two things that are possible. We don't actually know which is true, but H naught could either be true or H naught could be false. Right? Either the reality is they did it or they didn't do it. We don't know, but it's our goal to try to, based on the evidence, guess. So over here, this is sort of the reality of the situation that we cannot possibly know. H naught is true, they're actually innocent, they did not commit the crime, or H naught is false, they actually did it. So, if we go through this, I want to figure out what goes in each of these. Is it a correct decision, or was some sort of error made? And so if we start over here, the idea is the reality is H naught was false. H naught being false means the null hypothesis isn't true. It means basically this person actually committed the crime. And over here, if we reject the null hypothesis, so we reject the idea that they're innocent, right? So again, H naught being true, that's the idea of, so let me just write this up here. They did it, or they didn't. And over here, this is a verdict of guilty, and this is the verdict of not guilty. This is the analogy. So over in this box here, the idea is they actually did it, and what was our verdict? Our verdict was guilty. So that means we made the correct decision. They actually committed the crime. We found them guilty of the crime. This is a correct decision. Similarly, in this case, they didn't commit the crime. And down here, if I pick not guilty, and they didn't commit the crime, that's this box here, the not guilty, and they didn't commit the crime. This is our other correct decision. So there's two types of correct decisions we can make. We can make the correct decision where we convict them, and they actually did it, or we let them off, and they actually didn't do it. Those are both the correct thing. These other two are going to both be errors. So for example, right here, the person didn't actually do it, but our verdict was guilty. We convicted an innocent person. This is what we call a type 1 error. And I'm using the Roman numeral 1, but you're welcome to just write the number 1. That's fine. I'll know what you mean. So that's a type 1 error. And again, type 1 error is the person was actually innocent. We convicted them. We convicted an innocent person. The second type of mistake is they actually did it, but we let them off. So we let free an actually guilty person. So that is what we call a type 2 error. And it turns out that, so basically, to summarize these, the type 1 error is that we convict the innocent we rejected the null hypothesis even though it was actually correct, it was true. And a type 2 error is we find somebody that was actually guilty innocent. So we let off the guilty. And both of those are mistakes that are possible to make here. One question is, which of those is the more egregious mistake to make? Our justice system is set up to try to prevent one of these two types of errors as much as possible. And so if you think about it, this one, a type 1 error, this is considered worse, a worse mistake to make. This is considered more egregious. If I can write that word, egregious. God, it was John Adams or one of our founding fathers, I don't remember, so don't quote me on this, had a statement that said they'd rather see 100 guilty men set free than a single innocent man convicted. And this is why the bar of conviction is so high in our court systems, that it has to be beyond a reasonable doubt to convict somebody. We want to make a type 1 error as infrequently as possible. So that is the idea. We want to make type 1 errors as infrequently as possible. Later on, in the next couple of sections, we'll actually have a way of figuring out exactly how likely this type of error is to occur. And so I'll mention that hopefully in the video for section 9.2 once we start doing examples. But let me do just one or two other quick examples to see if we can figure out what kind of error occurs in a given scenario. So maybe our hypothesis test has the following. So we have a null hypothesis that says that mu is equal to 90. And we'll have an alternate hypothesis that says mu is not equal to 90, which would make this, by the way, a two-tailed alternate hypothesis. And the reality of the situation is, in reality, the true value of mu is 80, and we reject h naught. So at the end of the day, h naught gets rejected. So we've set up a trial, and we, at the very end, entered our guilty verdict. Is this an error, or was this the correct decision? Well, looking at it, the real value of mu was 80. The null hypothesis said that mu was actually 90. So it turns out in this case, h naught was false. H naught wasn't true. And what did we do with h naught? Right, if mu had actually been 90, h naught would have been true, but it wasn't. Mu was actually 80. So our h naught is false in reality. And what did we do? We rejected it. So that makes this a correct decision. We correctly rejected our null hypothesis when our null hypothesis wasn't true. For a second example, what if our hypothesis test has the following? H naught is that mu is equal to 50, and the alternate hypothesis is that mu is greater than 50, which would make this thing greater than 50 would be a right-tailed hypothesis, going back to that terminology if we needed to figure that out. In reality, the true value of mu is 51. And in this case, H naught is not rejected. Is this the correct decision, or is it some sort of error? Well, in this case, our null hypothesis is that mu is equal to 50, but the reality of the situation is that mu was actually equal to 51. So H naught was not true. But what did we do? We didn't reject it. We said, hey, H naught may be true, and we were wrong. So this is an incorrect decision. It's an error. We just need to figure out which one it is. The idea is H naught wasn't true. They were actually guilty, but we rendered a verdict of innocent. So this was the same as basically letting off somebody that was actually guilty. And that is, as we can see up here at the top, that is our type 2 error. So this is a type 2 error. The easiest way to do these problems is pretty much just go refer to the table itself, and we can do it real quickly if we just look at our table here. Type 2 errors occur whenever H naught is false. Type 1 errors occur whenever H naught is true. And so we just need to know whether or not our H naught was true or false. In this case, H naught said it was 90. It was actually 80. So H naught was false. That limits us to one of these two results. And in this case, we rejected H naught. So that means we made the correct decision in this case. Boom. In the second one, we said the null hypothesis was that mu was equal to 50, but the true value was actually 51. So again, H naught was false. It was wrong, which again narrows it down to one of these two results. But in this case, we found a not guilty verdict. We didn't reject H naught, right? We said H naught is not rejected. So that means that we've got a type 2 error, and that's where that result comes from, right there. So next time we'll actually do an entire hypothesis test. So far we've just kind of been working on this idea of what the process is going to look like, what our decisions are going to look like, and what our initial hypotheses are going to look like. So we're going to put all of this together in the next video and do an actual example from section 9.2.